All right, what I want to do today, before we get into quadratics in any major detail and factorization, is to talk about and introduce the term itself. Because one of the major disconnects that people have is with the term itself, right? And the term quadratic, when we read it, we tend to read it not quadratic. We tend to read it quadratic. And quad as a prefix might suggest four, right? And in a way, it still does. But this is derived from Latin terms. And those terms are quadrus and quadratus. Well, can I spell? Let's see. All right. Both of which in ancient Latin would mean square shaped or four sided. Now, again, you're thinking, there's a four again. Does that disprove what we think? Well, it also means squared, right? And in our algebraic terms, something squared is something that multiplies itself. Now, how might that present itself for ancient civilizations? For us to get to the point where we say quadratic and we know, hey, we're dealing with an equation that has its highest power being squared. Well, let's consider a scenario, right? Let's give ourselves a scenario. Here's our story. So let's consider our ancient Greek king, right? Could be Babylonian, um, let's say what else? Maybe Indian. I don't know what the term would be for a king in ancient India. That not probably not being the name of the area at the time. However, we have our king. He has demands, and we have our contractor, right? Now the king wants a couple of things, right? King needs demands. He needs a 60 square unit lot of land, right? To be used fully to create, let's say, a rectangular structure. If it's rectangular, he needs one side to be longer than the other. So he's going to have longer side, and I need to let's edit that up a little bit because I have an issue with this pen at times. All right, so the longer side is going to be 3 units more than the shorter side. Now, if I'm the contractor, I know a couple of things. I know that the longer side is 3 units more than the shorter side. I know it's rectangular. So I just sketch up for my king. Yeah, no pause. I sketch up for this king my rectangle. That's a rectangle, people work with it. And my shorter side, I'm going to just call X, right? But this shorter side is 3 units less than our longer side. So our longer side could be X plus 3. And the overall area would be 60 square units. Let me go units squared, right? How else can we express this? How else could this be written down? Well, we could say under our circumstances, let's see, I can get our main players there. I could say to the king, hey, well, if this is my rectangle and the area is 60 square units, then x, because it's a rectangle, times x plus 3 would be equal to 60. At which point, and that's 60 square units, we could expand and we could say x squared plus 3x is equal to 60. Moreover, we could say x squared plus 3x minus 60 is equal to 0. At which point we could then attempt to solve for x, right? Now, what you'll notice is a very familiar form here. This x squared plus 3x minus 60 is equal to 0 is our quadratic form. And our quadratic form simply expresses a polynomial here where the highest power of x is going to be squared. So our quadratic form as we know it is quite literally a term in x squared times some constant plus a term in x times some constant plus a constant which is equal to 0. Here, a, b, and c are constants, and a cannot be 0. So this is our quadratic form. That's the form that we're used to, and all it means for us is that the highest power of x is 2. So we have x squared. And that is the basis on which we start looking at quadratics in terms of, you know, what they are. Whenever you see a polynomial where the highest power of x or highest power of your unknown, your variable, is 2, it's going to be quadratic. And of course, we have three constants there, a, b, and c, where a and b as constants, since they multiply an unknown, a variable, are called coefficients, but they're all effectively constants, right? So this is our quadratic form. This is just a quick explainer of where the term comes from. Whenever we see now quadratic, we can think of it not as quadratic, but more quadratic, where we, of course, looking at the derivation of the term coming from the Latin quadrus or quadratus, right? And here we'll just think of it going forward as meaning squared. So hopefully that does give a bit more context. When we get back in, what I want to do is for us to just do some basic factorization. We'll start using some factorization by grouping. Then we'll get into factorization of quadratic terms using that idea. And then we'll talk about completing the square. But that I will set as a totally separate video. So the next video will just be quadratic factorization and getting you comfortable there. All right, don't forget to like and subscribe.